This tutorial will start backward. So I will first run the pre-built simple genetic algorithm Java application. And next I will use the output from running this simple application in order to quickly explain various genetic algorithm concepts. And lastly, I will step by step build the application using an Eclipse IDE. This is a pre-built application. So if I run it, we went from generation 0 to generation 3, and if we run it again, we get a completely different output. So now we went from generation 0 to generation 7, and each one of those is a chromosome, and a chromosome is a potential solution. And here we have a population of chromosomes, and I am sorting each population by fitness. So we have the highest fitness first, and what fitness means in this case is how many genes are the same as the ones that are in the target chromosome, and each one of those is a gene. So in this particular case we have 10 genes, and of those 8 are the same as the ones that are in the target chromosome. And we evolve from one generation to the next by doing selection, crossover, and mutation. And we will be going over those while writing the code, and included in that will be elitism. So this genetic algorithm ends when one of those reach a fitness of 10, means the same as the number of genes in the target chromosome. So this is exactly the same as this. Next, I'll write the code step by step. So this project will be running on Java 8. And it will have a chromosome class. It will be in this package, and a chromosome represents a candidate solution, and it will have a population class representing a population of chromosomes, and a class that manages the operations of the genetic algorithm that I will just call genetic algorithm. And the application driver class that will have a main method. Next, let's go to the chromosome class. Here, a position in this chromosome will be called a gene. So we'll have an int array representing those genes, and you will have a constructor that takes in a length and instantiates that array given the length. And for the population, we'll have an array of chromosomes and a constructor that takes in a length and instantiates that array given the length. And going back to the chromosome, to initialize those chromosomes with random zeros and ones, we'll have this method, initialize chromosome, that randomly assigns ones or zeros to the various genes in this chromosome. And let me go to the genetic algorithm and define this public static final int array. So the target chromosome representing the solution, and going back to population, we define this sort chromosome by fitness method that I will be coding shortly. So the same as in chromosome, we had this initialize chromosome method. In population, I will have this initialize population method that instantiates chromosomes and call initialize chromosome method on them and puts them in the array of chromosomes, and then call sort chromosome by fitness to sort them and return this population. And let me have a get method for this chromosomes that will just return it. And going to the chromosome class, have this toString method that will print out the content of this array of genes. And I will have a get genes method that returns the genes, this array. And let me define fitness representing the fitness of this chromosome, and a get fitness method that returns this fitness. And I want a method that determines the chromosome fitness by comparing it to the target chromosome. So let's define this method, recalculate fitness, that compares each gene in the array of genes to the genes of the target chromosome, and adds 1 to this chromosome fitness each time we have a match, and then we return the chromosome fitness. And let me here define this is fitness changed, and I'll set it to true initially, and here in get genes I'll set it to true, and in get fitness I'll check if is fitness changed, then recalculate the fitness and set that is fitness changed flag to false. And let's go back to population, and for this method sort chromosome by fitness, we'll be using Java 8, and it takes in the chromosomes array, and this should do it for population and for chromosome. Next, let me go to the genetic algorithm class, and I'll have this method crossover population that applies crossover to all chromosomes in the passed in population. And for now, let's return the same passed in population. And I need another method that applies mutation to all chromosomes in the past n population. I'll have this method, mutate population, that returns for now the same past n population. And let's have a public method, evolve, that takes in a population and evolves it. So it does that by calling crossover population on that population, and what's returned from that method, it goes ahead and calls mutate population on it and returns the result. And let me here define this public static final int population size, and let me for now set it to 8 chromosomes. Now going to the driver class, I will instantiate a population given the population size and call initialize population method on it. And let me define this public static method, print population, that prints all the chromosomes that are in a population, and prints a heading also that is passed in, a title. So the initial population here will be population 0. So generation 0. So I'll print out the fittest chromosome fitness in that generated population by doing population.get chromosomes. And since I'm sorting those chromosomes, so if I take the 0 position in that array, I'll get the fittest chromosome, and I'll pick up the fitness of that chromosome. And I'll call this print population method to print out all the chromosomes in that generation. So let's go ahead and run it. Here we go. So generation 0, the fittest chromosome we got is 9. So this is the only difference between those two chromosomes. Everything else is the same with the target chromosome. And now let me go ahead and instantiate a genetic algorithm. And define this int generation number, and have a while loop that checks the fitness of the fittest chromosome in the population against the fitness of the target chromosome, and goes to a next generation if we haven't reached this fitness yet. So here for this new generation, I'll do a genetic algorithm.evolve, passing in the old population, and we get the new population. For now we get the same population since I haven't coded those methods yet. So afterward I'll do population.sort chromosomes by fitness, and then do the same as we did for the generation 0 for the chromosomes in generation 0. So we will print the generation number and the fittest chromosome fitness, and then we'll print the population. So now if we run this, it should keep running because it will get the same chromosomes each time. So let's do that. So here we go, it will keep going. Since all the chromosomes will be the same. This is exactly the same as this one, and this one is exactly the same as this one, etc. It's the exact same population each time. Next, let's go to a genetic algorithm and define the number of elite chromosomes. So basically, elite chromosomes will not be subjected to a crossover or mutation from one generation to the next. So in crossover population, let me define this crossover population. A new population of the length of the previous population, and let's go ahead and return this crossover population, and let's exclude those elite chromosomes from crossover and mutation, so they will move as is to the new population. So I will do the same thing here to mutate population. Define a mutate population and exclude the elite chromosomes from being mutated. Next, let me define this method, crossover chromosome. For now, let's return null. So this method does a random gene selection from each one of the parent chromosomes and puts that in a new chromosome before returning it. Let's call that crossover chromosome. Let's return it here, and this code will do the random gene selection. So if mass.random is smaller than 0.5, the crossover chromosome will pick up genes from chromosome 1. Otherwise, it will pick up genes from chromosome 2. And we have a loop here going through all the genes. And next, let's go up here and define this tournament selection size, and this is the tournament population size, and this is used for chromosome crossover selection. And let's go down here and define this method. Select tournament population. So in tournament selection, a number of chromosomes is selected randomly, and from those, the one with the highest fitness is chosen. So let's define here this tournament population and return it. And this code will pick up a number of chromosomes randomly. And let me sort the tournament population before returning it. So sort chromosomes by fitness. And now in crossover population, I'll go ahead and loop through all the chromosomes in the population except the elite one. So here we will start from 1, since number of elite chromosomes is 1. And we will select 2 chromosomes. So we will do select tournament population and then pick up the fittest chromosomes from each tournament population. So we got chromosome 1 and chromosome 2. And now we call the crossover chromosome method, passing in those 2 chromosomes, and put the resulting chromosome in the crossover population. And what remains is one method, mutate the chromosome that applies randomness to this chromosome before returning it. So let's go up here and define this mutation rate, and this is the probability that a chromosome gene will do random mutation, and the range is between 0 and 1 and is usually small. So it is actually usually smaller than this, but for the purpose of this tutorial I used this number. So now if we go back to that mutate chromosome method, have this loop, and here I will go over all the genes in the chromosome, and if mass.random is smaller than the mutation rate, in this case 0.25, then we will go ahead and do random mutation. So if mass.random smaller than 0.5, then we'll assign 1, otherwise we'll assign 0. And if the mass.random that we obtained is not smaller than mutation rate, then we keep the gene the same in the chromosome. So now let's go back to the mutate population method, and call the mutate chromosome method on all the chromosomes except the elite one. So we're starting from 1 in this case. So let's save all and go ahead and run it. So we went from generation 0 to generation 7. And if we run it again, let's see what we get. We went to generation 10.